Hello everyone, today we'll be discussing chapter 2 from the book that I've been reading, Designing Machine Learning Systems by Chip Young. So yeah, let's dive into the topic. So this presentation explains the overall content from the chapter 2. It's better to read a book always, but I'll just give a gist on what are all the things that are covered in chapter 2 so that you can just go back and read it, you can understand it effectively. And the first thing, reading a technical book is not a easy task like a fiction books. I kind of read the chapter once or twice. As I'm a beginner, I just got started with. And I convert this entire thing into a podcast. I listen it 3 to 4 times and then I try to understand. And that when that's not enough, you need to try to see things in this particular point of view that what you read. So I'm just trying. Let's see how it goes. But yeah, coming to the topic. So chapter 2 is all about fundamentals of machine learning system designs. So let's see what it actually is. So this chapter actually helps you to move from the regular student mindset to the production level mindset. As a student myself, I generally think about the code plus data is equal to the model, and that's all that matters. The main goal is the maximum accuracy, and the basic context is static data sets, and then endpoint would be deployments in the finish line. But that's not it. But when it comes to the production dataset, it includes a number of things. Actually, as I told in the previous chapter, model is just like 10% of the actual system that you'll be working on. We have data pipelines, monitoring, business logics, serving layer, value extraction, and many more. The main goal in the production level is to solve the business problem. It's not to get a good accuracy. Obviously, getting a good accuracy is one of the things, but the main target and goal should be solving a business problem for the client that you are working with. So if you got very good accuracy in a particular model, and if you are showing to the client, he doesn't even understand what it exactly means. He just needs how does it matter to the business. That's the goal. So just think on the other point of view, the business point of view, and then the context here is shifting data. You'll get a good understanding about it as we are going on. uh, and then the endpoint is deployment into the start line. Sorry, deployment is the start line. So the ML lifecycle here is not a one-time thing. It's not like a race that has an end. It's a loop continuously going on. You will be getting initially the data you will be training the model on. Then you will be working on the data, training the model, deploying, and then a new data comes up. It's not like a one-time data. New users comes up, their pattern changes, their behavior changes over time. So you need to train the model like, again on the new data. It's just a cycle; it never ends. So you need to keep an eye on it. Deployment is just the start line; it's not the finish line. And training a model is the easy part. Sorry, just a second. This goes right. Training a model is the easy part. Building a system that generates value is a goal. Okay, yeah. So what it says from the book, I took a tagline kind of thing. So training, we were always thinking training a model is the hardest part and it's the core component of the entire ML lifecycle, but it's not. It's the easiest part, kind of, not completely. But the main goal here is to build a system that generates a value. I'm sorry if you're unable to say it. Yeah, the system that actually generates value. That's the goal actually at the end. So yeah, what are the things that we will be covering on? I'll just walk through the entire chapter fast. So what is the actual goal? I mean, what are the areas that we will be covering in the chapter? So the first thing is understanding the business and ML objectives. What is the golden rule of value? And then the system requirements. Uh, the 4 pillars of production when you are working on the production level applications. And then the iterative process, framing ML problems, and then mind versus data, which actually outperforms, which drives the success, basically. Yeah, that's the key things that we will be discussing on today. Yeah, starting with the golden rule, business objectives and the ML objectives, which actually plays a key role, right? So here the basic concept as a beginner, here the basic concept is as a beginner, you obsess over ML metrics like accuracy, FL score, or low latency, right? But as a pro, you need to understand and you basically realizes companies care about business metrics like revenue, user retention, and cost savings. It's not completely on the accuracy part, on the metrics, mathematical technical terms. They won't even understand it. So the major disconnect here is increasing model accuracy from 94% to 94.2% is useless if it doesn't actually adds value to the business. So based on the business requirement, we need to understand things and work accordingly. So the major translation here would be you must translate the exact business goals into the ML metrics, not the other way around. For example, you can see if a business wants to increase ad revenue, a business metric, and then the model metrics might be the click-through rate. So the ads generally work on number of clicks, right? But here there might be a small trap. that sometimes better model hurts the business. So if you are actually working on the click-through rate, the example that they described in the book, uh, if there are some thumbnails that were interesting and the content inside that thumbnail is junk, there will be a higher click-through rate to that particular thumbnails. But eventually, does it actually it increases the quantity of the clicks, but actual quality of the content, it completely ruins everything, right? That's how the traffic to the website decreases. Here, the model that you gave is working perfectly fine. It's working on the number of clicks, but for that particular ad. But eventually, the content that user is experiencing, it doesn't have any value, and the website goes down. So that's the major point that you need to understand. Accuracy doesn't always gives the best results to the business. So you have to understand that point. So before even writing the code, the major think like a pro point you can consider from this thing. Before even writing a code, if the model achieves 100% accuracy, how does it actually help the company make money or save time? So that's the major question that you need to consider. If at all the model is giving very good accuracy, how does it actually help the business? Do you have any edge cases on the top of it? So if you can't answer this particular thing, you don't need to build the model at all. You don't question yourself after building the model. The entire you'll be wasting the time on it basically. So yeah, that's the thing. And the major four pillars of the system requirements. They are the standard pillars. You need to uh, work on them. You will be working on them almost all the time. So they are reliability, scalability, maintainability, and adaptability. Generally, just to kind of remember it, I remember them as Raskelma kind of thing. So okay, yeah, that's how it is. Reliability. What reliability actually means? Uh, as I told, ML fails silently. It's not a software that crashes if there is a different type of input or something. It basically gives you a bad output. That's it. It doesn't crash. So you need to understand uh, how the things are, how reliable the model is, and you need to keep an observation on it all the time. And then comes the scalability, the resource management. It's not just about the traffic volume. It is about auto scaling GPUs and managing the artifacts over 100 different models. So basically, when it comes to production level, you won't be working with a single model. So you need to understand and scale the entire system accordingly, and you need to automate this entire system. You won't be sitting at the computer at 2 a.m. or 3 a.m. in the morning, changing on these resources when the data or requirement changes, right? You need to maintain the scalability and automate it at the same time. And maintainability. So what maintainability actually means? It is like how easy is for a different person to use that particular work that you have built. So you don't force one tool on everyone, right? Ensure the code that you are writing, code or data, whatever you are working on, are versioned so anyone who are coming up in the future to join your team can reproduce the same model exactly, so that it won't break anything. And yeah, basically that's the main thing. So that's the maintainability of the entire system that you are trying to build. And adaptability, once again, as I told, the data shifts. It doesn't maintain the same patterns and structure all the time. So the system that you are trying to build requires a manual retraining for every data change. It is completely obsolete. So you need to keep an eye on the adaptability of the data, the change of data, and retrain the models accordingly with the change of patterns. Yeah, those are the four pillars. And coming to the iterative process, basically, as I told, yeah, the ML lifecycle, it's not a one line thing. It doesn't have a start and an end, and you can't just move out of it once it is done. It's a never ending process. It's basically starting with the project scoping, data engineering, ML model deployment, sorry, ML model development, and then comes the deployment, and then comes the monitoring and continual learning. And then the business analysis comes in, and that's a loop. It goes on and on as the business requirement changes or adapts. You need eventually the business any business need to adapt to the market over time, right? As those adaptation changes and the new types of data is coming in, the you need to work on the entire life cycle one more time. So it's a never ending process. You need to understand that particular thing. And one more thing, so thinking like a pro in this particular section would be like expect to go backward. You will deploy, realize the business metric doesn't move, and you have to go back to the project scoping or data engineering, and then the process is never finished. So that's the baseline that you can remember when you're actually working in the production level. And coming to framing the problem itself. So uh, you need to basically yeah, you're generally let's consider a scenario where your boss gives you a vague problem like customer service is too slow. You must translate this particular problem into a mathematical problem with inputs, outputs, and objective functions. So generally, considering the type of task, we might have different types. You can consider them as a classification problem or a regression problem. Let's say in classification, we have generally we'll be putting the things in different categories, right? It can be binary, that is two classes, multi classes. I mean, you have many classes, but only one is correct. and then you have the multi-label part where you have many classes and multiple can be correct at the same time, and so on. We have different classification and regression types. You need to understand the which type of task is required for the given problem statement effectively, and then you can work on it. And yeah, reframing this problem, you can also consider it as sometimes you should change the task type to make it easier. Yeah, in one of the scenario on the book, so they were, yeah, this particular example, just a sec. Yeah, so the main thing is you need to understand. So yeah, designing begins actually by fitting the business problem into the correct mathematical frame. That's how you need to basically, if the question or the problem is vague, you need to understand how better you will be fitting that into the mathematical formation, and then you can actually start working on it. We'll just take one example scenario. So how to reframe a given requirement. So the scenario actually have this predicting which app a user will open next. So that's a basic problem statement that we got. Generally, as a beginner, you might be considering you can actually classify this. You can consider this problem as a classification, and you can bucket the different types of applications and predict according to that. Let's say you create a multi-class classification, and the output is the probability of every single app installed. And if the user installs new app, you have to retrain the architecture again. So that's the problem that you will be facing when you are working on this classification part. But when it comes to a problem framing, you can actually do a regression problem where the input is the user plus app's features. What is the behavior of the user and the features of the app instead of the app itself, so that you can understand, you can actually get the output of the score for that particular app according to the user behavior as well, on how likely they will be clicking on that particular app. So that's the regression problem. So consider the change. It's not like you need to consider only classification to these kind of problems and regression to these kind of problems. You need to change based on the behavior and requirements. So at this particular situation, even though a new app is installed, you don't need to retrain the model to understand which bucket it falls in. You can understand the basic features of the app, and then the actual model works for that to understand, to get the score of the particular app. That's it. That's how you need to reframe the entire problem statement according to the scenario, according to the situations. So yeah, that's the thing. And then the objective function conflicts. So yeah, there is a situation, as I told, yeah, the example I told earlier, when you consider, okay, so yeah, sometimes there is a situation where you might have a conflict between the multiple goals that you are working on. Like the goal one is to get the maximum clicks, and goal two is to minimize the clickbaits, the example that we discussed earlier. So in this kind of scenario, these are complete opposites, right? The model can't work on two opposite things. So here the major solution that you can think of is to decouple the objectives itself completely. Build a model that works on one thing and a different model that works on different thing, and then try to club their results together. Like instead of generally, when it comes to beginner, they will be trying to create a complex loss function that works with the quality loss and the engagement loss as well. But at a pro level, train two different models separately. One predicts the quality and the other predicts the clicks, right? And then combine their scores after prediction and get the best one after combining those both scores. You are not basically combining the entire model itself. You are just combining the scores and then allowing to tweak the balances between them without actually retraining the models completely every time. So that's the major difference between a beginner and a pro. Pro tries to complicate things, building complex, formulas to get effective results. But thinking as a pro, you can actually decouple them completely, work on them separately, and then just combine the scores to get the better results. That's how you need to think. It's a completely different way of approach. And then, yeah, the solution, as I told earlier, you need to just decouple both of them. You just create a rank function that gets best out of both, and then the final recommendation. So here the major rule of thumb is to keep the conflicting objectives separately always. And then comes the mind versus data thing. So I'll just give a quick example of this. I'm not sure if everybody relate to that. If you're actually trying to go to gym to build a muscle, get into shape, you are training your body like, let's say, 2 hours per day, but you are eating junk the entire day. Will you be able to see the results? I'm pretty sure you won't be able to see the results, and you know that why, right? So that's exactly how it works in the when you are working with ML models as well. doesn't matter how much training I mean, how much time you are training the model. It matter what you are feeding the model, right? If you have junk data, the model doesn't work at all, no matter how complex the model is. So you need to first work on the data and then work on your complex algorithms or models. So eventually, what you understand, the data always wins. So our general methods that leverage computation, that is processing massive data, consistently beat clever human design rules. So generally, considering the example, it's not an example, it's a reality. Google always wins and sits on the top of the layer because it have lots of data that it can train upon. That's the thing, that it is able to adapt to any new technology faster. And not just the superior algorithms. It doesn't have the algorithms, it has the big brains in their companies. Along with that, they have the data. So that's the key thing. Stop tweaking the architecture for 1% gain and spend the time on cleaning the data. Uh, yeah, the entire complexity, the entire results of the model relies on the data that you have. The cleaner the data, the better the results. That's it. So eventually, at the end, the system designer's checklist would be value first. If mm, sorry if it generated a different form, but yeah, the value first. If it doesn't move the business metric, don't build it. The business metric is the key. That's the main thing. And then comes the I mean, expect silence. The silent failures is the key. So you need to keep an eye on them. Build monitoring for silent failures, monitoring systems for silent failures, and work on them constantly. Not yeah, and then close the loops. Plan for continuous monitoring and retrain from day one. So yeah, it's you need to understand basically that's a closed loop, and you keep an eye on constant monitoring of retraining the data for the different types of data that is coming in, and maintain the entire system from day one for the end of the day crashes as well. And then decouple separate business objective problems goals when they are conflicting. And then comes the data first. Better data is always higher prior to. I mean, yeah, better data is always carries the higher priority than the complex neural models as well. So that's the key role. I hope you understand it. Yeah, I'll try to explain things better and faster going on. But yeah, I hope it added some value. Let's see in the next session. Thank you.